So this recording is Module 2, which is Single Area OSPF version 2 configuration. Now I'm starting off with the objectives. The list of objectives is very important. It's easy to kind of click right through and start at the first slide for this module, but I wanted to draw your attention to the objectives. These are the objectives that you need to know not only for this chapter, but for your CCNA certification. You will have to know how to configure OSPF version 2, whether you have to actually configure it on a device or whether you have to be able to troubleshoot it for the CCNA exam, but it's an extremely important concept. So you'll want to use each of these objectives as a checklist and make sure that when you get to the end of Module 2 that you can be able to know how to do each of these. Also pay attention to the wording. So I learned this after years of studying for the CCNA certifications, that you'll want to pay attention to the wording when you're looking at objectives for the CCNA certification, especially. For example, you have OSPF router ID configure and OSPF version 2 router ID. If it says configure, that means you may have to actually configure it. You'll need to know how to configure it step by step. If it says verify, then you're probably looking at show commands. If something we're saying to identify or to understand, then that would refer to the theory part. But if it says configure, make sure you know step by step how to do that. So I thought I'd just throw that out there as something I have learned from my own experience on how to study and prepare for the CCNA certification and how to actually use each of the objectives listed. So OSPF uses a router ID. As mentioned in Module 1, I talked a little bit about how a router ID is used to identify each router in OSPF. OSPF version 2 is enabled using a router OSPF configuration command. So after you enter that, the router goes into a router configuration mode. You'll actually see the prompt change to this mode right here. You may hear it referred to as a global config mode. Again, the routers use a router ID. This is similar to an IP address. You can use these are used by the routers for synchronization between the OSPF databases. They're also used for designating a designated router and a backup designated router, used in that election process, I should say, for the DR and the BDR. Now, the way that this is actually used is in this order. So you can configure a router ID using that command. We'll look at that in a minute. If a router ID command is not configured, then the router will choose the highest loopback address. If there is no loopback address configured on a device, it will use the highest active IP address. So it goes in that order: router ID that's been configured, highest active loopback, or the highest active IP address. Now, to configure a loopback, we did this in the earlier courses for CCNA, where interface, loopback 1, you enter the IP address, command, the IP address, and the subnet mask. So loopback looks pretty similar to that, but it's usually 1.1.1.1, 2.2.2.2. It's kept pretty simple. So if you wanted to configure router ID, you would go in and enable the routing protocol using the commands router OSPF and the process ID, which is 10, which would signify that version of OSPF or that group of devices that are using the same set of OSPF instances or routing protocols. And then you would issue the router ID command for that particular router. You can go in and modify that. You can go in and just type router ID and type the new router ID if you want. So moving on into some of your other syntax for OSPF. When you configure devices, you also have to configure them with a network address. And then with the OSPF, you also have to configure something called a wildcard mask. Now, a wildcard mask sounds very similar to a subnet mask, and it kind of is, but an OSPF uses a wildcard mask. This wildcard mask is used to match the information in your network address bit by bit. When you look at a wildcard mask, it is typically the inverse of whatever you would use for a subnet mask. So the zeros in a wildcard mask mean to check, while the ones mean ignore. So let's look at an example. So if you had the 192.168.14.64, this is a /26, what would your subnet mask be? Your subnet mask would be 255.255.255. So I'll type that in here. Now, how am I coming up with this? Well, if you know your CIDR notation, which is the /26, then you should know the equivalent subnet mask for that. If you have questions about that, let me know, but that should have been covered in your CCNA version 1, and then maybe again in CCNA version 2 course. So for a /26, the subnet mask that would be associated with that would be the 255.255.255. Now for the /26, that will be the first 2 bits. So that would be the 128 and the 64, which equals 192. So 255.255.255.192. So the inverse of that would be this. If I wanted to make sure that the network address matched exactly to the 192, I would do all zeros to check. If I wanted it to match 168, 0 to check. 14, 0 would check that. Now for the 192, in order to figure out what the inverse mask is, the best way to do that would be to draw that out in binary if you're not sure. So if I look at Word, I have actually drawn this out. Literally, I hand wrote this out. So I hope you don't mind my messy handwriting, but just to show you an example of how I would actually do it. If I were in the classroom, I would be showing you this method. So if this is the 192 right here, so how did I figure out what the one, or actually this is right here, this is from 192. So 128 and 64 equals 192. Now, when you're looking at your wildcard mask, you're trying to check bits or match bits. So the address ended in .64, and you want to match up the network part. So if you're looking at this, this becomes the network side, this becomes the host side on the side of the line. You want to match up the network bits and check those. So in order to check it, you would use a 0 and you would use a 0, because 0 means to check this bit. I want it to match exactly, but the other bits are 1s. 1s mean ignore. So if you were to look at this, this particular value equals 63. So by entering that value, that would check the first 2 bits and ignore the others. So you would type that in here. So notice it says correct. And there are other new problems you can do also. So if I were to look at this one, for example, so we're looking at the /27. Now we know that's 255, 255, 255, and that should be 224, because /27 would be the, if you're looking at it in terms of this, it would be the 128, the 64, and the 32 would be the placeholder. So if I were to actually draw this out, if you're looking at 128, 64, 32, so this would be your dividing line for your /27. It would be right here. So then you'd have the 16, the 8, the 4, the 2, and the 1. Okay. So again, if you're looking back at this exercise, so you have the 224. So if you're trying to figure out what your wildcard mask would be, again, you would want to check it, or you'd want it to match the first part, the second octet, the third. Okay. And then for the 224, so 224 looks like this. So 128, 192, 224. Your inverse would be the opposite. So you'd want it to check these numbers and then ignore these, which would mean that would be a 31. So you would have a 31 here. Another way that you could do this is look at what your subnet mask would normally be. So your subnet mask would normally be 255, correct? So this is 224. So if your subnet mask is normally 255, you're doing 224 is the one you want to check, subtract it. That'll also give you the same number as you got there. So that's another way they do it. So you could have done that before here with the 192. You could have subtracted 255 minus 192 to come up with 63. So whichever way works for you is fine, as long as you know how to do it, because this will be very important. Not only will you use this for calculating your wildcard mask for OSPF, but you will also need to know this for access control lists when we get to that section as well. So make sure you know how to calculate your wildcard mask, and then once you do, you can configure it. So you turn on your routing process by issuing the command router OSPF 10. This is the process ID number here. Then network and each one of your networks. So if you want 10.10.10 network to be used, which is right here, it's using area 0. We can see that in our diagram. And then you would type, you just basically hit enter, and then network 10.1.1.4, which is this one. And then its wildcard mask, area 0. And then network 10.1.1.12. Its wildcard mask in area 0. So look at this first wildcard mask of the 10.10.1.0. Notice the wildcard mask is 0000.255. So what they're actually signifying here is that they want the network numbers to match up, but they really don't care what is in the rest of the network about the particular ID of each device, as long as the network's numbers match up. That's all they're concerned about. So they've issued that, each one of those commands. Now, what happens if you need to reconfigure it, or you want to use, in this case, they're showing you IP OSPF command. Okay, so here what they've done is gone back into router OSPF 10 and then issued a no command in front of the same command that you used to issue the initial command for that device. So we originally did network 10.10.1.1 mask area 0. You can just do a no in front of that, and that will remove that command. Also, if you just misconfigure, if you typo something, that's the same thing you can do. And for the most part, it works that way with any command that you issue on a Cisco device. If for some reason you didn't configure it correctly, just issue a no in front of that and it will remove that command. And if you've entered that recently, then that should be one of your last 10 commands that's held in the buffer on your input, like when you're typing in. So you can just use your up arrow, scroll through your last 10 commands, and then probably find it there and issue a no in front of that. In this scenario, they're actually showing you how to use the IP OSPF command. And instead of using the address, they're actually specifying which interface to include that on. So that's what you're being shown here. And you're having a chance to try it out in the syntax checker. Now, there could be some scenarios where you want to have an OSPF enabled interface, but you don't want it to receive the updates. By default, each OSPF enabled interface will receive all the updates, but you may want to restrict your amount of bandwidth or your resources, or you don't want a particular OSPF enabled device to have unnecessary messages. Okay. So you could have an OSPF enabled interface listed as passive. If you wanted to list an interface as passive, you just go into your routing protocol, so router OSPF 10, passive interface loopback 0. That would make it passive. You would actually see it listed when you use your show IP protocols command. Passive interface is loopback 0. You have a chance to try that out using this particular syntax checker as well. There's a lot of show commands with OSPF. So if you're not sure when you're first starting out, use your show IP OSPF space ? And that will show you the OSPF commands that you can use. In this case here, they're looking at show IP OSPF interface G000. You can see the designated router. You can see who is the backup designated router. So you can find out a lot of detailed information by using the interface command. Now here we're using the pipeline. So show IP route is what we use to look at our routing table. And then they're using the pipeline and looking specifically at 10.10.1. Now, if we're looking at this, we can tell that it's a loopback interface because it's a /32. Loopbacks are used to simulate a network. So you might use this on a practice environment when you're simulating a real network to make sure the routing process works. And then when you deploy it on a real network, then you actually be using that address. The O indicates OSPF. Okay. This is always your network, and it's mask. When you're looking at the parentheses here, this is the administrative distance, so the 110 would indicate that it's OSPF. This is the metric that's used. This would be the next hop. This would be how long ago that you learned about, or the device learned about the route, and then this is the exit interface on that particular device. Now, if you wanted to configure on a point-to-point, this is how you would do that. IP OSPF network point-to-point. There is a packet tracer on configuring point-to-point for single area OSPF. Now, if you're looking at multi-access OSPF networks, that is one of your network types. Now, this is where we're going to get into configuring your OSPF designated router. Now, the different roles that you can have within OSPF for your devices would be your DR, your BDR, and then you have DR others. So those are what we're going to look at. Now, again, the role of the DR is to disseminate information. I showed you a video of that in Module 1. So rather than all the devices sharing all their information with everybody, we elect a designated router to do that for us. The backup designated router is there in case the designated router goes down. All the others are signified as DR others. Now, just as review on your DR and BDR, so your DR is the router with the highest priority number. Again, default is 1. The higher the number, it would be elected the DR. If you don't want a router to ever become the designated router for one reason or another, it's an older device, you can always set the priority to 0. The BDR is the second highest number, and that will stay the same even if another router enters your network with a higher number. Those devices will stay the DR and the BDR. So in the event that the DR fails, the BDR slides into the position of being the DR, and then the one with the next highest, or the highest priority number, would be the backup designated router. Okay. So that election process, might have to occur again for the backup designated router. So you can see here the designated router and the backup designated router. Okay. It appears that this case, they're using the router ID of the 3333, 2222, and the 1111. So in this case, the designated router would be 3333, backup would be 2222 because it'd be the next highest. When you're looking at your show commands, so in this case we're looking at show IP OSPF interface G000, you can see the designated router and the backup designated router. They are listed. You can also see the adjacencies that have been occurring. And you can do that for each one of your devices. You will see those listed. So make sure you review that. You see show IP OSPF neighbor. You can see the neighbor IDs and whether they're in the full state, so whether they converge, whether the BDR, whether they're the DR, and you can see that for each one of your routers. So you would go specifically to each one. So this is the process that I was referring to earlier about the election process. So the highest interface priority. Now again, this is where we have the information about the default being 1. 0 is, you would set a device to 0 if you don't want it to become elected. If the interface priorities are equal, the router with the highest router ID is the DR. So you can configure that router ID like we did earlier, manually configure it, then it goes to highest active loopback and highest active IPv4 address. This is the process I referred to earlier on what happens in the event of the DR failing and the BDR is elected. And then of course you would have a new BDR. So make sure you look over that information. You can also configure priority. So in order to configure priority, you can change that. As we were referring to earlier, 1 is the default, so you can change it. So in order to do that, it's IP OSPF priority. If you change these commands, usually you're going to enter this command clear IP OSPF process. Now, in Packet Tracer, I believe it typically takes it on the first time, but on real equipment, I've seen it entered for as many as 3 times before. It takes a little bit of time for this command to take effect sometimes. So if it doesn't take it on the first time, just re-enter that. So once you enter that, it'll kind of clear everything out, and then you can go in and look at it and see the new BDR or DR. You can see the priority numbers. But again, clearing that out will help. So that is the first part of this Module 2. It's a pretty long chapter. Make sure, in kind of a review, make sure you know the election process. Make sure you know how to configure your devices. Make sure you know what a priority number is, the difference between a DR and a BDR. Let's see. Be able to verify using your show commands. So these are all important things that you need to know out of the first part of Module 2.